Hey there, everyone. My name's Dave Hoelzer. I'm one of the SANS Fellows, and we're trying out a new thing here, try to do some live stream. And of course, this is going to be just about a complete demo here. So lots of things can go wrong. It'll be a lot of fun. And hey, nice to meet you, Alanazi. And I've got the comments up here too. So as I'm going through this, if you've got questions or comments, or especially when I'm writing some code, if you see me doing something wrong, let me know. Don't let me embarrass myself. But we're going to try this out. And this week and next week, this is planned to be a two-part series. What we're effectively doing are some adventures in machine learning and information security. Part of my interest in this is that in my role in my company, I kind of lead or oversee the research for machine learning and AI solutions. And one of the challenges I find, and it's the reason we're actually creating a class for this, that's specifically for applied machine learning for information security professionals, because I find that even if you do some basic instruction about it, people really wrestle with, how do I turn this into something I can use in production in my business? So what I'm going to do here today, and I'm going to get my share going here, is we are going to head toward a solution that allows us to do some real-time network traffic classification. And what I'm throwing up here on the screen right now is my machine with Jupyter running, and I've got a little notebook in here, and I've actually stolen some code out of something we use live. This is some Python code making use of a thing called Broker, which if you're a Zeke user or a Corelight user, you might be familiar with that. It's the communications library that's built into Zeke. It's how all the workers talk back to the manager and the log server and all that other stuff. Well, you can actually hook into that thing. And it's one of the most interesting features within Zeke, because not only can you automate what Zeke does with its own language, but because of Broker, I can push this data out anywhere and do anything I want with it. So what I've got running here, I've actually already, this isn't a dev Zeke cluster here, so just give that a second to get itself fired up. And Zeke is already up and running, so I'm not connecting to that again or starting it up. Oh, there we go. You can see some stuff happening down here. And I'm just going to interrupt that because we don't really need that running the whole time. But this Zeke is running with Broker and has a small script running that is just firing out the first 16 bytes of every stream that it sees. And along with that, it's giving me some other stuff, which I'm just formatting here. So this is all getting formatted in the Python code. But I'm grabbing what's being pushed out to me from the Broker stream, and I'm just parsing it out and printing it. For instance, there was a response from this host here from port 53. Here is the first 16 bytes, just rendered out as hex. And in fact, it's sending me that as a string, an ASCII string. As crazy as this is, within Zeke itself, you can access this data any way you want to. But if you want to get it out of Zeke, Zeke is very resistant to sending binary content anywhere. So I'm sending it out as ASCII because you can actually render it out as hex pretty easy. So that's the ASCII string it's firing at me. And what my goal is to say, is it possible for us to write a machine learning solution that will do two things for us? First of all, to be able to look at this content, and I'm just going to assume for a moment that it is actually a valid DNS packet. And in looking at it, I can see that it is. And we've got a DNS transaction ID here. Here we've got the flags. I've got number of questions, number of answers. Here's the beginning of a DNS name. So that's definitely DNS. I can recognize it because I work with this stuff a lot. But can I make the machine learning model recognize that as DNS and recognize that as the UDP Q Quick protocol, the Google Quick, so the TLS over UDP for HTTP2. And let's see, do I even have anything else here? No, that's it so far. Can I get it to recognize what those are? But even better, the thing I really care about, because we do real-time network monitoring, I don't care so much that there's DNS traffic on port 53. What I care about is there's some protocol going across the network that we don't think belongs here. Our network doesn't know anything about it. And that's the problem we want to solve. We're going to kind of try to do that together. And we're going to get through a part of that today. But I'm sure that there's going to be a bunch left over that we're going to come back to on Wednesday of next week. So we'll do it at the same time. And of course, we're recording the stream too. So if you can't tune in live, that is totally fine. Now I am just going to cheat just a little bit. I've just got some imports here that I'm going to grab. I've got some utility functions that I'll make some use of. These are just some stuff for plotting things out and for doing some basic conversions from a Python script I have. And we're also going to load up numpy and TensorFlow. And I would prefer to just do this with TensorFlow, but it turns out that TensorFlow is kind of lacking something that scikit-learn still has when it comes to taking lots of discrete labels and easily turning that into a different representation. It is possible to do it with TensorFlow, and especially to make use of embeddings to do it. That's just a little bit too complicated for where I want to go with this. Finally, I'm going to use this CSV stuff, and I'll explain what that's for in just a second. To really get started, though, I have to show you what I already have. Now, I showed you in my broker data that what Zeke is sending me is information about the host and the protocols and the first 16 bytes of data. It's listed as 32 positions or characters because it's rendering it out as hex, right? So 2 characters per byte. That's what it's sending me. And I've actually already got a bunch of that stuff somewhere around here. Let's see where it is. It's up here under training data. There it is. So I've actually got a bunch of these. Let me pick one that's not huge. So here, for instance, is this DLNA service client that we have running on our network here. So I've just had Zeke produce some examples for me that I'm going to use as my training data. So that's already been pulled out. This is super easy to generate. We're using a Zeke script to do this, where we just take the new traffic of interest. For example, I don't think I have Google Quick in here. So let's imagine I wanted to grab Google Quick. I wanted to populate that data set. All I'm going to do is configure Zeke to start logging out strings from real Google Quick data, and then just store it in this directory with that name, Google Quick, and the content. Because what my machine learning solution is going to do is translate that into a model and learn from it. How do we do that? Well, the first thing I've got to do is start getting my hands on that training data. So let's work on doing that. I know so far that the training data, and I'm going to try to be somewhat organized about this. I am kind of a stream of consciousness programmer, so we may come back and kind of revise some of the stuff here. But I know that the data, or the training data, is currently residing in training data over here. So let's get that set up. And let me just see what files I have there. Let me make sure that I'm actually able to see that. All right, so supposedly, fantastic. All right, so that's definitely got me a list of the files there. And what I'd really like to do is maybe grab the content of one of those and start building the training data. As it turns out that the actual machine learning part of this is really the easiest part. The more time-consuming thing is turning this into useful training data and kind of structuring it, especially trying to structure it in a repeatable way so that when I want to put this live in production, I've got something I can actually use. So let's start building this slowly. I've got the list of files there. What I'd like to do is maybe grab one of those and experiment with it. So let's say, with, what do I want to grab here? Let's grab one of those files. So if this is going to be inside of training directory or training data /, and I'm going to use just the first file. Let's just grab that, as F, that's fine. And let's just print that thing. Let's just make sure that works. Invalid. Oh, of course, I do have to put a subscript in there. That would be awesome. All right, fantastic. So it appears to be loading up that data. It has defaulted to using it in read mode. I sort of left that out there, but Python was kind enough to do that automatically for me. And probably what I want to do is maybe look at the content. So let's read that. There we go. I'm definitely reading the content. And from there, I'm likely going to want to view that as an array because I'm going to have to iterate over these lines. So let me just split those. There we go. So we've got an array out of that thing. And let's see what we're going to do with that. Maybe it makes sense. I can just grab that. And whoops, I think I've got an extra paren in there. Thank goodness for syntax highlighting. Let's do a 4 line in lines. And let's start printing some of this out. What I'd like to do is convert these ASCII bytes into bits. Now, let me explain why we're doing that. When you do work in machine learning, you can get away with not normalizing your data and not scaling it all down to be in a range from -1 to 1. You can get away with it. Just depends on your data, depends on your particular problem. But when you've got something you're building and it's behaving badly during training, if you have not bothered to normalize and scale your data, that is probably one of your big problems. In this case here, since I'm dealing with packets and packet headers, it makes a lot of sense to me that I should probably not try to scale these values. In other words, I could break this out into individual bytes that range from 0 to 255. So I could do that, and I'll bet this would be pretty good, but that's not in the range from -1 to 1, which is best. And it's got another little issue. I know from my experience with protocols, and you may know this too, that inside of these protocols, frequently little bits are used for things. Like I glossed over it, but when I had up that DNS data, let me just pull some of that up for a second. It's kind of a big file, but that's okay. So looking over here, I'm looking at this from my knowledge of network monitoring. So if if that's not super familiar to you, the Sec 503 course, there's actually one coming up in next month, in the middle of the month, where we go through the whole thing and how to parse these protocols out and really understand what's going on in your network, and then turn that into real-time monitoring. Well, from my experience, I know that those 2 bytes there, that's going to be the DNS query ID. And then over here, I'm looking at the query itself. What's happening? And I'm pretty sure what this is saying, the 8 there is, this is a query. If I remember correctly, that bit over there is indicating recursion is desired. But it's not the 8 that makes this a query. It's the fact that the high order bit is turned on, and that happens to be worth 8. But what if the other bits were turned on? Now, if I were to treat this as a value, a complete value, and scale it down, I'm sort of losing what those bits are doing. And instead, it could become kind of magical that when there's a number like 81, that means query, and maybe give it another one. C1 also means query, but it turns out it's that 8-bit that really matters. Well, to take advantage of that, if I just convert these bytes back out to bits, so 18 would become 0001, 1000. Well, now I'm naturally getting all of those bits, and it's the bits that matter, which is in fact the truth of protocols. But the other advantage is that naturally moves us to this range from -1 to 1. In fact, it's narrower than that. It brings me to 0 to 1. So there's just a little bit more cheating I'm going to do here. I have a function where I've actually worked out how to do that, because I don't really like to, I try to avoid anything but obvious list comprehensions whenever I can. And this one is a little bit less obvious for what's happening here. But what this effectively is going to do is give me a function I'm calling content to features that lets me pass in a string. And here I'm calling it bytes. It's actually characters that we're passing in here. And what it's going to produce for me is spit back out a list of bits. Let's just see if that works. So let's grab, let's see, where am I so far? So we've got line in lines. Let's actually not loop through that just yet. How about we do this? How about we print line sub 0. So let's just grab the first one. And what I actually want to do is, well, let's put them side by side here. Becomes content to features line sub 0. What do we get here? and print, blah, blah. Oh, it works better. Format strings work way better when you put an F in front of them. Fantastic. So it takes this wonderful data here. The 1 8 you see becomes 001, 0001, 1000, just as predicted. And I have now spit this out as a list of bits. Perfect. So with that done, I can do that for everything that's in this file. So let's make this back into for line in lines, in lines. And this is going to be less pretty, but I like to verify things as I go. It's actually one of the things I love about Jupyter, that I can just make a change and instantly rerun it. And that's clearly working just fine. But I do want to make a small change to this. What it's giving me is a Python list. And I'll tell you where I'm going. This is fine. This is totally fine for just looking at one kind of data. But at the moment, in that training data directory, I've got a whole bunch of different kinds of data, and I'm trying to build a training data set. So sort of my goal is to create a training data set in a CSV file that's going to have the label, so that's what the protocol is, followed by the bits. Because if I do that, that's going to be pretty easy to read back into a big training array and be able to manipulate it in a way that I can easily feed it to my network. So that's where I'm going. I want to make something that looks like that. So rather than just printing out the content here and the line, let's make a little change to this. Let's print out the file. Let's see here, with open file. So I'm currently not iterating over the files. So let's do for file. I feel like that's probably a reserved word. How about for file name in files? Add this over. Let's open file name. And then we're going to read all those lines in and print out the file name. And so this is going to give me the content of features. But like I said, right now what it's giving me is a Python list. So it's going to have these square brackets around it. I want to make those go away and turn it into a text-based list. So here's my thought. What if we tell it to join that data with commas? So that's just going to be a regular join. But I now need to apply an operation to this, because what I'm getting back is really not a Python list. It's actually a numpy array. So I'm going to have it run the map function against that and apply the str function to every one of them. In other words, convert them all to strings. And let's just, and that looks pretty good. So you can see I've got my label sitting in the front, DNS, followed by a whole bunch of bits. That's great. I can print them on the screen, but I really need them in a file. So let's get started with that. Let's create a file for this, out file, and I'll make that, let's see here. Let's open training data.csv to write. Just in case you're working with this yourself or choose to expand on this, maybe copy some of this code, I'm intentionally not making this an append, because if I need to retrain my model, I don't want to inadvertently keep appending new copies of existing training data, because that's actually going to end up skewing how my model works and skewing how my training works. So I'm explicitly overwriting it every time. All right, so that should open that file up. Let's see here. Is there anything else I need to do to this? I don't think so. Oh yeah, I need to write to it. So how about we do outfile.write. We're going to write that data out. And since I've switched from using print to write, write does not append a new line. So let's just stick a new line on the end of that. And I should be able to outfile.close. At least I think it's close. And see how that runs. Okay, it's not throwing errors. That's a really good sign. So while it's going, I'm going to start writing the next piece. I now need to load that thing back in. And this is why I imported the CSV library, is specifically to be able to reload this file. So let's do a with open training data.csv, read as F. And what do I want to do here? I want to CSV reader. I'm going to make a CSV reader. Will be csv.reader, instantiate one of these using a delimiter. I always spell that word incorrectly. There we go. So that should do it for opening that file. And let's read the stuff in. So list CSV reader. And let's just print that and see if that's successful so far. Now I do see, oh, it is just finished. So there's an extensive amount of data in there. All right, well, it hasn't printed anything, so that is mildly concerning here. Oh, wait, no, what have I got here? Data rate exceeded. Well, that's not a terrible thing. That means that it's printing too quickly for my Jupyter to keep up with it, and so it's going to just shut that thing down. Let's see if it created a file for me. CSV reader, 160 megs. All right, so I probably don't want to display that in a cell, but it does look like I was successful in creating that data. All right, then. So rather than printing it, let's pull it in somewhere that we can use it. Let's create a numpy array that I'm going to call data, and I'm going to create that out of this raw data, raw CSV, and then let's just see data.shape. All right, I've got something not quite. Whoops, I've spelled array incorrectly. That's bad. I thought you folks are supposed to be helping me out there. That's all right. Feel free. You see me do something crazy. And now I've got a memory error, unable to allocate for. All right. So I think what we're going to do here is maybe I'm going to restart and clear my output. And I'm also going to come over here because I don't remember if this guy is still working. Let's shut this kernel down. Just make sure I've got nothing else that's taken up any memory in this Jupyter here. All right, let's try this one more time. Just going to import that stuff, redefine that. I don't need to rerun all of this. So I'm going to move that to another cell. All right. So in here, I'm going to Alt-Enter on this one to just define that and paste this content back in here. I don't want to recreate the file. We've already done that twice. Training deer is not defined. Oh, I thought it defined that. Training data. Oh, how did we get away with that before? All right, let's try that again. That's better. All right, and let's just try to load that file one more time. Hopefully we have enough memory now. Really don't want to restart this whole thing. Unfortunately, my normal training machine just isn't available right now. So I'm actually doing this on a lab. It's actually on one of our network monitoring sensors, which doesn't have a GPU or any of that stuff. So it's going to be a little unhappy with this. Anyway, it looks like we were successful. We've got 5.9 million rows that are 129 columns each. And let's just have a peek at one of those. So there's one of them. We've got a DNS entry in there. So perfect. We have successfully managed to grab that data. What I next need to do is kind of pull that apart a little bit. I need to turn it into training labels and training data. The labels are going to be here in the first column. In fact, let's just print that out. So let's look at the first 10 and let's print out column 0. If you've done Python before but not worked with numpy, this is going to look a little weird to you. This is asking for the first 10 rows, so that's just the slice. But then I'm saying grab that column. And we could do that for a range of columns as well. So here it is showing me the first 10 of these are DNS, so those are all labels. And if I looked at the rest of them, so if I did 1:, they're bits. So it has correctly pulled the data in. I need to peel those apart, and I need to do something else. When we do the machine learning piece, which we're going to jump into next Wednesday, we'll actually build the network and run it. That's going to take just a couple of minutes. But when we do that, If I don't change this, I'm going to ask it to do validation. In other words, while it does the training, I want it to kind of step back and do a spot check to see just how well it's doing. And I'm going to make use of a feature that's built into TensorFlow that does this for me called validation split. Now, a more traditional way would be for me to split off validation data. I'm going to get TensorFlow to do it for me, but there's a small downside. There's a little thing to know about. If I do that, it takes the array as is and then pulls off the validation data as is. So let's say I gave it a 20% validation. That means that the last 20% of the data. Well, right now, my data is organized. Let's look at that first column again. So that all the DNS data is together, all the TLS data is together, all the NTP data is together. So if I asked it to do validation by pulling off the last 20%, it's going to be whatever the last 20% is, but it will not be representative of all the data that I have. So here's what I'm going to do. NumPy has a really cool option in it, or a really cool function called shuffle that's part of the random part of NumPy or package within NumPy. And it's sort of interesting because NumPy arrays are effectively immutable, but this changes the array. It's going to shuffle the array. So if I shuffle that and it shuffles it in place, there we go. So you can see my data has now been shuffled. Outstanding. That means that I can now start pulling these two things apart. So my X data, the stuff that's going to be used to train the model, that's going to be equal to data, all rows, and I want all of the last columns. That goes into data. But my labels will be data, all rows, and it's going to be column 0 only. And if I look at one of these, so X data sub 0, that is an array of bits as expected. And the matching label that goes with that is QTLS request. Excellent. My next step, what I want to do now is encode those labels, because as they stand now, they are a list of words. When I'm working with machine learning, I'm going to need to turn this all into numbers of some kind. And that's sort of an essence of machine learning, that it's all just math. Whether or not the representation we choose makes sense, that's an entirely different question. And since this is definitely an empirical field, meaning we're going to try stuff, and if the stuff works, we're going to say it's right. We're going to try just encoding this in some way so that I'm using maybe integers to represent all of the different labels that I have. Because, for instance, right now, I think I can do a np.unique against y labels. It shows me that these are all of the current labels I have. What I'd love to do is convert that into numbers. That is simple enough to do in Python, but if there's already a library that does it, I might as well use it. And that's the part that's sort of missing from within TensorFlow. It doesn't quite have that piece in it. So we're going to stop here for today, but when we pick up next Wednesday, we're going to pick up right here. We're going to grab scikit-learn and use a label encoder that just converts that easily into a dictionary for us. And at that point, we will be ready to push this through a model, train it, see how well the training goes, maybe tinker a little bit. And by the end of the session next week, we'll have a working thing that can find anomalous protocols in my network. Well, if you do have questions or anything else, feel free. All right, everybody, sorry about that. I accidentally hit the leave studio button instead of stopping my screen share. So feel free to reach out to me over email, or you can contact me through the SANS team here. We will be back with you next Wednesday. We'll pick up right here and we'll wrap this thing up and give you a working solution by the end. Thanks so much for coming today.